Good morning, I'm Rick Rowland. I'm here at RefTech. We'd like to discuss a topic today, just basically the topic of pressures in recovery cylinders. So there's a couple things I'd like to discuss, and the idea that, first off, what is the pressure going to be in a cylinder? So if we discuss how we might get gas in a cylinder and what the pressures might be, let's get started. One of the things we talk about is pressure itself. So if we look at a scale of like this, it says pressure. So how many different ways can we look at pressure, right? So if we open these valves up and there's nothing in the cylinder, then the pressure that we're standing in here right now is 14.7 psi. That's atmospheric pressure. But it also could be looked at as in vacuum. So if somebody had a set of gauges and they were open to this atmosphere, the gauge would read 0, whether it be psi or inches of mercury. Normally the vacuum in a cylinder would be measured by inches of mercury, but the pressure would be psi-G for a gauge. So the other thing that people do too that we should get familiar with, if we're going to vacuum this cylinder out, we should be associating microns. So right now, if the pressure that we're at here today, if this valve were open, in that cylinder, we'd have 760,000 microns. So let's do a good practice. We're going to clean this cylinder out before we start to put gas in it. So what we would do is hook a vacuum pump to it, and we would start to evacuate this. So when we do that, the pressure in the cylinder on a gauge would go from 0 and start to count down in inches of mercury. When it gets down to a perfect vacuum, theoretically, it would be at 30 inches of vacuum. And also the 760,000 microns would be down to 0. Now that's hardly an attainable number, but in the refrigeration industry, 500, 400 microns is a good practice. So if we were going to recover this and getting ready to put refrigerant in the cylinder, if we brought it down to 1,000 to 500 microns, that's really a good job. So one of the things I want to help people understand is that somebody says, is there liquid in this cylinder? When I start adding refrigerant to it, when would liquid start to build up in this cylinder? So the next thing I want to show you would be the idea that we're going to add refrigerant by this little chart here. So we did a good job, and we vacuumed this cylinder out to 30 inches of mercury. So I'm going to put a source of refrigerant into that cylinder and start to add it into the cylinder. As I do, if I'm watching my gauge, and we should get a gauge to show this, and that I would be going from 30 inches of mercury, it starts up 15 inches of mercury. I'm putting refrigerant in this cylinder. If I get to 0 inches of mercury, that means I'm basically at atmospheric pressure. I keep adding refrigerant. That gauge keeps going up. And at 10 pounds, when I put 10 pounds of refrigerant in that cylinder, the question would be, is there any liquid in that cylinder? And the answer is no. We have to keep adding pressure until we get to the point that the pressure and temperature chart applies. So let's say we put 10 pounds of pressure in there. So with 10 pounds of pressure in there, you wouldn't have any liquid. Let's use 410 as a reference, until you get to, if you look at the pressure and temperature chart, this is something specific to any particular refrigerant, assuming it is all 410. But when you look at this chart, you see we're going to add pressure to this until it's 225 pounds if it's 77 degrees here. So with that said, when the pressure goes above 226, we'll start to make liquid in here. And whether we have 2 drops of liquid on the bottom or if it's halfway full, if the temperature of that liquid is 77 degrees, the pressure on a gauge will read 226. So that's a little confusing to people sometimes, because if we have 10 pounds of liquid in the bottom, or if we have an 80% full tank, if the temperature is 77, that refrigerant 410 will have a 225 pound pressure. So with that said, one of the things we want to be sure that we do is that when we're working with recovery cylinders, The reason that you would make sure that it's evacuated is because imagine we didn't do a good job and we got the refrigerant out of here, but it's been left open, and there's air in there. There's 14 pounds of pressure in that air. So if I don't evacuate that air and I start with that pressure in there, all that temperature pressure chart, when I make a drop of liquid in here, I'll be about 15 pounds of pressure off, because it's an additive factor in the idea that the air pressure is going to add to the refrigerant pressure. So then when you start seeing systems operate, the pressures are all too high because I let that air mix with my refrigerant. Air is a big problem. So we should be making sure that we recover these cylinders completely before we start adding refrigerant.